Surveys are a common part of our everyday lives, and they can appear in many different variations. In this instructional video, we will attempt to break down the fundamentals of planning and conducting surveys in order to develop a complete understanding of the art of surveying and how it changed the world of statistics. Before we dive in, let's briefly go over the characteristics of a well-designed and well-conducted survey. It must have no bias, or as little as possible, no confounding variables, and it must use a random and representative sample that was selected using the proper techniques.
To continue, we will address some definitions. A population is the whole group of individuals that we are trying to get information about, and a sample is a subset of that population from which we actually collect data from. An example of this would be if we were trying to find out how many people like avocados in San Diego. It would be extremely difficult to get everyone's opinion on the matter because there are approximately 1.4 million of us. The idea is to take a smaller grouping of the 1.4 million and ask them the question instead. Furthermore, random selection is when we take a sample from a population in which every subject or individual has the same probability of being chosen. The purpose of this random selection is to take a sample that is truly representative of any given population.
So I'm going to go over briefly the types of bias that you can have in a bad study. So it can be seen in sampling and surveys. I'm going to go over sampling first. So you have voluntary samples and convenience samples. These two are bad sampling methods. Voluntary sample is when you give a general invitation to people and people can pick if they want to respond to it. So people who are very strongly, feel very strongly about the subject are going to respond. And that's going to lead to a very heavy overestimation. At the same time, you can also have a convenience sample, which is just as bad, and that's if you take the first 20 people or make it so that you're selecting a population not randomly. And that means that you're going to be unrepresentative of the entire population because you're taking maybe the first 20 people who are stepping out of a grocery store, and those people are going to be similar-minded because they're shopping at the same time, while people at night might be looking more for ice cream or impulse buys or something like that. Those people shopping at 3 and 4 might want more healthy things. Then there's undercoverage, which is a type of bias seen in surveys, and that's when some members of the population are not represented in a sample. And then there's non-response, which is an individual who was chosen for the sample can't be contacted or refuses to participate, and that can often skew what the generalizations can be made about the population. One of the biggest misconceptions is that non-response is the same as voluntary sampling. It's not. Non-response is only occurring after a sample has been selected, but in voluntary response, every individual has opted to take the part and do the sample. So the two aren't exactly able to happen at the same time. And if you're ever trying to figure out how a study design leads to bias, you need to identify the problem with the design and then explain how problems leads to an under/overestimate.
It's important to remember that there are many different types of sampling, including simple random sampling, stratified random sampling, and cluster sampling. Simple random sampling is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as a sample. Stratified random sampling classifies the population into groups of similar individuals, therefore strata, then chooses a separate simple random sample in each stratum and combines them into a simple random sample to form the sample. Now, cluster sampling classifies the population into groups of individuals that are located near each other. Clusters then takes a simple random sample of those clusters.
In order to create random digits on a TI-84 Plus calculator, select the Math button, then slide to PRB or Probability, and scroll to RandIn, which is the random integer generator. Then enter the given lower and upper boundary numbers into the function and select Enter for however many numbers that need to be generated.
Don't forget to describe what population you want to learn about and what we want to measure.
Here we have a sample AP question. Feel free to pause the video and answer it for practice.